I'll start out by explaining the XML help file. And first we have some basic includes, including the string.h in order to split a string into smaller tokens that we can analyze. Then if we are on a Windows, we define these string tokens and scanf in order to use them later. Then we have a recursive function used for going through our linked list, made up of all the data from our XML file. We then have functions for extracting the property out of the nodes in our linked list, and we have a few of these. We have the function here for extracting the property from the node, and then we have a few functions for converting a property into either floats of different lengths or ints down here. So what it does is that it creates an array of characters according to how many characters there are after the comma in the data we want to extract. So if there's only one number, we use the property to float. If there's 3, we use the property to float 3 and 4 and so on. If we don't know how long they are, like their coordinates or something that has different lengths, we use the property float array, which creates a dynamic length array that we can use. And we have one for both float and integer, as we also have different varying lengths of integers in the XML file that we'll need to extract. That's it for the XML help file. So let's go on to the PNG texture file. We again have some initialization of some variables and some basic includes for the include before using include and so on. We start out by loading our texture, which is we start by making a variable for the image, and then we initialize and generate one image name, and which we then bind to a ID and loads in the image when we run this texture or this load texture function. If we were successful in doing so, then it will create all this, applying or making info variables for storing the info, and flip the image and or if the origin is in the wrong corner, as it would be on a Mac, then we'll flip it. Otherwise we'll convert every color component into unsigned bytes, and then we generate a name and what to call it when we have to find the texture. And some height and width and RGB of the image. And that's basically it for this file. Then we'll go on to the main. where we again have some includes and define a lot of global variables. We can have this definition of the texture file as a glue int, and we have a lot of arrays of floats, which is the data that we extract from the XML file. And some of these arrays are very big, as there is a lot of data to store, as such as the texture coordinates, or down here we have some indices and vertices, and normal vectors that also have to be very big. We also define a MISC, which is pi, that we are using for a formula for calculating how the camera is supposed to be. Then we have our init function that initializes all the things that we are using for our viewports, and lighting and textures and all this that is needed to construct our model with the texture and the whole stage that we have, such as background color, and initializing the window size and window position and such. And we have the draw function, which is where we're drawing all the data that we get in, or using all the data that we get in to draw the model and apply textures. We start off by setting the camera in the right position and rotate it according to what it says in the text file. And here you can see we are using the pi from before. We then go on to setting the light, where the light is and in which direction. Then we go on to where the object is. Start to apply some materials. These are not to be confused with the color, as that is the texture, but more how the material is affected by light. As you can see, is the diffusions, how specular it is, or how shiny it is. Then we initialize our texture and bind it to the object down here. And we then have set up our vertex array after neighboring it, and do the same to our array of normal vectors, and then we draw the model out of all these triangles and indices that we use. And then we have to make sure to disable all these arrays again in order to create the most effective program. And since we are using buffers for all these data, we have to flush it, which pretty much empties the buffer. And then we are using the swap buffer in order to swap the front and back buffer, so that we are able to draw the next frame while we are still viewing the current frame. And then we draw the other frame in the other buffer, and then we just swap them and then start over again. We then have a function for reshaping reshaping the viewports according to the text file, and a function for quitting if we so desire by just pressing Q. Down here we load in all the values from the XML file, which you can see here we use the property to float that we were looking at earlier in the XML file, and we are using the different lengths of these 3 and 4 and 1 in accordance to how many decimals is on the number that we want to load in. And down here in vertices with the coordinates, as I said earlier, they have different lengths, and therefore we have to have a dynamic array, as we don't know how long each of them will be. And we do the same with the texture coordinates, as we don't know how long they will be either. And in the main function is where we load in our files. You can see we use the load texture file from the PNG texture header, and then we run our different functions, the draw, the reshape, and the keyboard was used to quit, and then we're just using the making the main loop, and that's basically how it functions. And I hope you enjoyed the video.